To Physics Lab 1. This lab focused on constant velocity and our ability to assess moving objects. The objective for Lab 1 was to utilize our knowledge of physics principles to analyze, observe, and evaluate the motion of an object moving at constant velocity in one-dimensional motion. We were able to accomplish this by using the app Tracker, data applications such as Excel, and using GlowScript to construct a computational model through code and matching this with our observations. Using these tools and physics principles, we were able to compare data, construct graphs, and come to a conclusion. Some important information to get out of the way is that the system for our video was a marker, and the surroundings was everything else around the marker. So a meter stick was used to calibrate or approximate the distance traveled by the marker over time, and using tracker, different time points of the marker itself were captured at different positions, and this enabled us to make a position versus time graph. Here is a video displaying that. So here in the video, you see these red dots following the marker, right? So those dots are getting the position and the time of the marker at certain increments. The blue line above going across horizontally was the calibration stick, and it's following a meter stick that is used to follow the calibration of the meters, and we have the time going as well. As you can see at the bottom right, we have a table where we are measuring time, X position, and Y position. So in this lab, we're only looking at one-dimensional motion. So for my graphs, I ignored the Y portion of the position and only looked at X. And when you look at my coordinate system, you can see that it's slightly rotated to the right. And the reason why this is rotated is because it's trying to follow the direction of the marker. So I only took into account the X position. There it is one more time. So this is a screenshot or two screenshots of a position versus time graph and a velocity versus time graph. So if you look at the position versus time graph, you can see that we have a linear slope here. So when we have a linear slope on a position versus time graph, this indicates that there is constant velocity. So position and time with that slope being linear, that means that it's going an average amount of meters per second. Therefore, we know there's a constant velocity. And also, therefore, we know that there's net force, the net force is zero. And when we look at the velocity versus time graph, we can see that the slope is zero. And there is no increasing, there's no decreasing, it's just zero. But it's at 0.275 almost. And that is to indicate that it's moving at this velocity, but constantly. It's not changing at all. Also indicating no net force. So on the left here, you can see my code that I used to compute the models that you just looked at. And you can see that the position started at the origin 0, 0, 0, and the velocity of the ball was 0.2739 meters per second. This was calculated by taking the final position minus the initial position over the final time minus the initial time. And the time steps were in increments of 0.03 seconds, so that was my delta t, and time started at 0. So we use a while loop to run the function to make the graph, and you can see that the net force was 0, and I have my velocity final equation, which is equal to the initial velocity plus the net force divided by mass times change in time. But my net force is 0, so it's not necessary to include the rest at the end there. So my ball, the velocity, not of the ball in this case, but of an actual marker, is the same each time through every time step. And the position is found by using the position equation, which is the initial position plus the average velocity times the change in time. And this is done over and over again, infinite times, until it reaches 2.06 seconds. So here's the observed curve versus the computational model. So the observation is a bit different from the computational model. So the only difference is that they start at different positions. The y values are relatively the same, but the x's are not. The reason that this is like this is because in my video, I started tracking the position of the marker at about 1.5 seconds. But when I put it into the code, I started from 0. But if the video started at 0 seconds exactly, then these would be fairly identical. So what if the marker moved in the negative x direction? If the marker moved in the negative x direction, then we would have had a negative velocity, but the speed would still be the same. And what are all the forces acting on the marker? All the forces acting on the marker are gravitational force, normal force, frictional force, and the applied force opposing the frictional force. So in this lab, we review constant velocity motion in one dimension, and we use graphs to display our results and come to our conclusions. Thank you.